I'm a hydrogeologist. My motto in life is think out of the box. My name, Marcel. My experience, groundwater and soil contaminations. I'm the creator of Geo RGB, a channel of geographic information systems, GIS, geology, hydrogeology, and contamination. The purpose, the objective, the goal, the intention, the target, the desire. Share my experience and acknowledge to create points of discussion. The Geo RGB community. Promote the use of free and open source software. A free digital society. Provide technical advice to environmental companies. An opportunity for professional growth.
Hello guys and welcome back to my channel. In this occasion I'm presenting the Geostatistical Analysis course related to the creation of groundwater flow maps with Kriging Interpolation. We are going to be working with R and Rstudio for the geostatistical analysis and graph design, and with QGIS for the final map edition. We are going to compare the results we get with the Geostatistical Analyst extension of ArcGIS to see how we can get the same results. However, ArcGIS is a private software, but Rstudio and QuantumGIS are open source and free software. I am going to create a series of video tutorials where you are going to learn how to create a Kriging interpolation successfully. Unfortunately, Kriging interpolation is a kind of black box where most of the people just press the button next without understanding what is the math behind the Kriging method. However, in R, there is no button for next. In these tutorials, I am going to explain with examples, step by step, the spatial analysis methodology, where I'm going to be talking about exploratory data analysis, experimental semi-variogram, model semi-variogram, cross-validation, Kriging interpolation, and also at the end we are going to be working with the map edition with QuantumGIS and also reporting results. This is the second video of the Geostatistical Analysis course, and in this second video we are going to talk about exploratory data analysis. Before to apply any Kriging interpolation, we have to answer these two couple questions. Does the data follow a normal Gaussian distribution? Is the data stationary? To answer these questions, we are going to do a geostatistical analysis and also map interpretation. Also, remember that if you missed the first video about the introduction, you can hit the card located at the right corner of your screen, over here. In this second video, we are going to talk about the first question, and we are going to leave the second question for the third video. Let's go to do it. The first point is why we need a normal distribution of our data. Well, Kriging is driven by Gaussian process and estimate the mean value of the phenomenon. It means that the normal distribution is very important. In ArcMAp, we have a couple of tools to identify if our data is normal distributed. We can use the histogram and we can use also the normal QQplot. Let's go to start with the histogram. Then here you have to make sure you select the parameter you want to analyze. In our case is the groundwater. Then just hit on the groundwater and here you can choose the number of bars you want. And also here you can take out statistics showing here at the top. As you can see in this graph, we have a pretty good normal distribution. As you can see, the graph is pretty symmetric, and also the mean and the median, it's pretty similar. The values are pretty similar. If your distribution is not normal, you can apply some transformations, for example, logarithmic transformation, and also box-Cox transformation. You can play with these parameters to look for a normal distribution of your data. But in our case, we are not going to apply any transformation because our data is normal distributed. Also, I'm thinking to do another example with a contaminated area where we are going to apply a transformation to see how it works. But for this exercise, we are not going to apply any transformation. Okay, now let's go to see how we can make a histogram using Rstudio. The last day we leave Rstudio like this. Now I'm going to take out all these ones, remove all this information here, remove this one here, and take this one out, and let's go to start with Rstudio. I'm not going to write the scripts because that one is going to take time. Yes, I'm going to copy and paste because I did already the job, and that one is going to be a faster way to work with the tutorial. To start, let's go to see how we can install the packages and load the libraries. To install a package, it just has to write install package like this one, and between code marks you have to add the name of the package you want to install, and then run. And it's going to take some time to install the packages. Just leave the computer. Here you have an icon when the system is working. Another way to install packages is just going to here, packages, install, and then here with this option here, with CRAN, just write here the name of your package you are looking for, select the package, and then press the button install, and it's the same process. Also, sometimes you want to install packages that they are not here in CRAN. Then you can choose this option here, package archive file, but then you have to look manually for the package you want. Okay, sometimes all the packages are not here. There are specific packages that maybe you want to use and you cannot find that ones in CRAN. Then you have to look that ones manually in websites or something like that. Remember that you need internet connection to download all the packages. Here at the screen, as you can see, the sentence starting with a pound is just for a note. It's not part of the coding. In this case, these notes make a description of the package we are going to use. Okay. For example, in this case, QGplot 2 creates elegant data visualization using the grammar of graphics. For example, this package, read Excel files, okay? And each package is doing something very specific. Now let's go to run all this one. Just select the one you want to run and press the button. And now all the libraries are loading successfully. Okay, now let's go to load the data we need. Just press this button here. From text, base. Select the folder you have the data. We created this data at the video introduction is this one. Then open. Check everything is correct. For me it's good. 4 columns, X, Y, groundwater, and label for the piezometers, then import. And we have the table here. Now we have 2 tabs, one for the scripts and another one for the table. And also we have our data here. That indicates that we have 57 observations and 4 variables. As you know, this one is not a variable, it's just a label for the piezometers. Clicking over here, you are going to get also some information about your data. Now let's go to move to the next section. The data is already loaded. Now we are going to view the data and some statistics. The first script is just to view the table, this table. Then if you run this script, we are going to go to the same table. For the second one, we are going to see what kind of variable it is A. As you can see, that one is a data frame. The next step is to create a backup of our data. We are going to put df because data frame. Then let's go to create a backup. As you can see, that one is going to appear here. But both of them at the moment are the same, but later I'm going to change this one for a different kind of variable. Then the next one is to see what kind of variable is ADF, but as we know it's the same as A, data frame. Also for viewing the table is this script. Just click here and then it's going to appear a new tab over here with this table. This script, the names is just to see the name of the columns. X, Y, groundwater and piezometers for the piezometer label. The next one is just for to see the 6 first points of information. Just the first 6 for the X, Y, groundwater and piezometer label. Then summary is just to see some statistics for all the variables we have on the table. X, Y, groundwater, and this one doesn't have any information because it's just letters. The important thing here is that the mean and the median, they have pretty similar values. Also we have the minimum value, the maximum value, and we have the quantiles also, the first and the third. The next one, it's related with the distance between the points. The short distance between the points is 12 meters and the longest distance is 453 meters. We are going to see this one now on the map with QuantumGIS. Let's go to open. Recent projects is this one. And as you can see here, for example, the small distance between the points maybe is this one. And if we mark that distance over here, it's just approximately, okay, 11.843. Okay, it's approximately the same distance as we saw here. Okay. But that one is the good one, is the real one. The one we did, it's approximately. And for the longest one, maybe it's this one from here to here. And the distance is 453 meters, okay? That's the one we saw here, 453. And this one is for calculating the variance. And the variance for the groundwater parameter is 2.19. This information, this one, the distance between the points and the variance, we are going to use to do the semi-variogram. That is a very important information, and we are going to be talking about the semi-variogram in the 4th video. Now let's go to see how we can create the histogram. Okay, we are going to see the histogram and the frequency curve. Let's go to fix this one a little bit. Even all this coding looks like very complex for the first graph. It is not complex, okay? We have to build a histogram like in small packages. The first package is where we add what is our information and what parameter we want to analyze, okay? If we run this first part of the script, we are going to get the frame of our graphic without any information. Then if we add the second part, is this part, plus the first part, we are going to add more information, like the bars. Okay, it's easy if I show you. Then if we press this button here for zoom, we can see all the graphic in a big screen. We can change all these parameters. This one is for the number of bins. For example, if we run 12, it's going to add one more bar. Also, we can change the colors and the fill. For example, this one is how much transparent you want this graphic. If we put, for example, 1, it's not going to be transparent. Let's go to run this one. Okay, and 0.5, and this one, for example, is going to be what color we want for the lines of the bars. For example, we can add a number 2 here for a different color, and this one is the fill, for the fill color of this one. We can add, for example, also here a number 2 and run how it looks like. This is part of the addition of the graphs. Okay, that one, then we say that one was 8 and that one was 1. That was good for me. Then for the next one is for the labels. Okay, what labels you want to add. Let's go to run this part. Okay, you can see here count, here groundwater elevation, and also the title and the subtitle, as you can see here. Then we can edit all these things here with the next part of the coding. You can see now the title is at the middle. And let's go to run everything to see the final result. Okay, that's the final result, and if we make zoom, that's how it's going to look like. I decided here to put raw data because we didn't make any transformation of our data. As you can see also, this histogram looks pretty symmetric, and it indicates that we have a normal distribution. But to have another graph where we can see that information, I'm going to now create a graph related with the frequency curve, where we are going to plot also the median and the mean. Is the next script. Okay, let's go to fix this one a little bit also. This one is longer because we added more information. Okay, like the mean and also the median and different colors. Okay, let's go to run all the script to see what is the graphic. As you can see here, we have a very well bell shape, and also we have the mean and the median very close. That indicates that we have a normal distribution. Now let's go to see how we can create the normal QQplot on ArcMAp and then with Rstudio. Let's go to ArcMAp. This is our data. Then go here, select Explore Data, and it's going to be this graph, normal QQplot. Then make sure you select your parameter. In our case, it's groundwater, and that's it. We don't have any transformation. Everything is good. A normal QQplot compares how your data lines up with a normally distributed data. Okay, as much point you have on the line, it's better than normal distribution. But in our case, it's not really bad. There are some points here out and also over here and over here out, but the distribution is quite normal. Now let's go to see how we can make this graph with Rstudio. Let's go to copy here. And let's go to fix this one a little bit. This one is as before, but here we need to add this sentence here, sample, for this kind of script. Okay, but as you run just the two first parts, you are going to have this graph, okay, without labels and without titles and anything. But if you run all the script, you are going to have everything, because all the information is here. For example, labels here with the names of the X and Y, and also for the title and for the subtitle, and also there are some additions for the axis. Okay, let's go to run everything together, and as you can see, we have the same result as we have with ArcMAp. Now let's go to see a couple of tests we can do with R to have also a better idea about our normal distribution. We are going to apply for the test for normality. We are going to do first Shapiro-Wilk, and then let's go to run this script here, and we are going to get a value. As the p-value is greater than 0.05, then we can assume normal distribution. Now we are going to do a Kolmogorov-Smirnov test. Then you have to install this package. I have the package already installed. Then I have to run just the library, okay? Again, in this case, I have the p-value that it's greater than 0.05, and also it indicates that we have a normal distribution. Then the result for both tests indicated that our data is normally distributed. This is the end for this second video, and remember that for the third video we are going to be answering this question: is the data stationary? And we are going to create a bubble map, voronoi map, and we are going to do an analysis trend of our data. Thank you very much for watching this video, and see you on the next one.